You're listening to Conferences Online Allergy from Children's Mercy Hospitals and Clinics in Kansas City, Missouri. Today is July 8, 2016, and I'm your host, Dr. Jay Portnoy. Our topic today, allergen immunotherapy. Our presenter is Dr. Harold Nelson. He's a professor of medicine at National Jewish Health in Denver, Colorado.
Good morning, everyone. Welcome to the start of the summer series for 2016. As many of you know, we changed our COLA series for the summer and basically have a series of lectures from now through the end of September on basic topics in allergy and immunology, geared especially for the first-year fellows who are starting. This morning, it seems appropriate to start off that we have Dr. Nelson, professor of medicine from National Jewish, talk about immunotherapy, which is one of the things that distinguishes our specialty. Dr. Nelson has numerous papers on immunotherapy. He's done research for many years on immunotherapy, and I don't think there's anybody in the world that has probably more knowledge on immunotherapy than Dr. Nelson, and it's a true honor and pleasure that he's here with us this morning. Dr. Nelson.
Okay, Jay, you'll have to help me a little with the mechanics here. I see you and I see the screen. Can I change these slides from here?
Probably the best thing to do is just say next slide, and we will move the slide to the next slide.
Yeah, because I can't move them.
Yeah, it's easiest to just do that. So just say next slide.
All right, very good. Well, good morning, everybody, and let's have the next slide, please. First, I should say I have no conflict of interest with this talk. So we're going to talk about the present status of subcutaneous immunotherapy. And as you see listed on this slide, the characteristics or the advantages that have been established for subcutaneous immunotherapy by carefully performed studies. So first, there's proven efficacy in allergic rhinitis, asthma, Hymenoptera sensitivity, and some patients with atopic dermatitis. There are identified effective doses. There are studies that support the use of multiple allergen mixes subcutaneously. This will be a difference that when you hear your talk on sublingual, in that has not been established. We have a plausible mechanism of action. It's no longer a black box. And there's demonstrated prevention of new sensitizations in monosensitized patients. You'll notice it has never been demonstrated that there's a difference in polysensitized patients. There's an effect on the progression from rhinitis to asthma. There's an established duration of treatment and persistence of efficacy after stopping. Next slide, please. The disadvantages are, of course, the inconvenience, and that's primarily that the injections have to be given in a healthcare facility with somebody available to treat a systemic reaction should it occur. The occurrence of systemic reactions, and then the rare but always present risk of a fatal reaction. So on the next slides, what we'll do is look at each one of these and talk about a couple of studies that support the particular characteristics. So the first one is efficacy. If we could have the next slide. We see here a study that was performed by Steve Durham, one of the foremost experts and investigators in immunotherapy in the world, comes out of London, England. This was a study of patients who had failed symptomatic treatment for allergic rhinitis the previous grass pollen season. So they were randomized to either placebo or active treatment a few months before the grass pollen season. And what we see here on the left is the grass pollen count in London that year. In the middle, we see the symptoms, and the blue dots are the patients who received placebo, and the red dots are those who received the active grass immunotherapy. And on the right is the use of rescue medication, and I don't think the colors came out right, but those most afflicted are those on placebo, and the red are those who received the active treatment. This, as you can see, is quite successful suppression of symptoms and medication use after just a short pre-seasonal course of immunotherapy. The next slide, we see a study from the United States. This is by another of the foremost investigators and experts in immunotherapy, namely Phil Norman at Johns Hopkins. This was the second year of a ragweed study, and see here in the dashed line are the ragweed pollen counts in Baltimore. In the green, we see the symptom medication score for those who received placebo. In the red, we see those who received the ragweed treatment. Now, in both of these studies, you're seeing 60 to 80 reduction in symptom and medication use. And just to put that in perspective, what would you expect if you gave an antihistamine? The answer is about 12 to 14% reduction compared to placebo. Start a nasal steroid after the patient has become symptomatic, which is the way they're more often used, the reduction in symptoms is about 18%. So this clearly is far and away the most effective treatment for seasonal allergic rhinitis. Next slide. There has been more dispute about its effectiveness in asthma. This was dispelled by this publication by a group of Australian pulmonologists. You can see appeared in Allergy in 1999. You can see there for each of the different groups, the top is mite, the second grouping is pollen, the third is miscellaneous ones. There was a big difference, a big variation in the degree of efficacy, with sometimes no efficacy at all. This probably relates to patient selection, dosing, and other factors. But if you look at the bottom diamond for each of the three groups, you can see that the meta-analysis indicated that it was indeed statistically significant. And then, as you'll note in the text, this has been periodically updated, the last in 2010, by which time we were able to identify 88 double-blind, randomized, placebo-controlled trials of subcutaneous immunotherapy in patients with asthma, about half of them with house dust mite, and most of the others with pollen. Overall, the reduction in symptom score was significant, standard MDA of minus 50.59, which is pretty good, not spectacular, but pretty good. And there was also significant reduction in medication use and in both specific and non-specific bronchial hyperresponsiveness. The next slide shows another of the Cochrane systematic reviews and meta-analysis. This was for the use of Hymenoptera venom immunotherapy, 7 controlled trials with ants, bees, and wasps with 392 participants. And with the subsequent field stings, the active experienced a 2.7% systemic reaction rate compared to a 39.8% reaction rate in those who received placebo. Also, as has been appreciated now, there's a significant reduction in the large local reactions, which can be quite debilitating to the patients. There are, of course, risks of systemic reactions as listed in the last bullet. And the next slide will show us still another systematic review, this one in the use of immunotherapy for atopic dermatitis. They identified 6 randomized placebo-controlled studies of subcutaneous immunotherapy in patients with atopic dermatitis, a total of 395 subjects, and overall there was a significant improvement in atopic dermatitis in those who received the active treatment, both in the meta-analysis and in 4 of the 6 individual studies. Almost in all cases, this was immunotherapy with house dust mite extract. Next slide, please. So now we'll look at the question of effective doses, which I think you'll appreciate from the next study is very important. Next slide, please. This was a study by Tony Frew, again in England. Again, these were patients similar to the patients in the Steve Durham study. They were ones who had failed symptomatic therapy. But this was conducted not in an allergy clinic, but in general practices in the UK. And this possibly explains the somewhat less effectiveness. But there were 347 adults who again were given a single pre-seasonal course of subcutaneous immunotherapy with Timothy grass extract. The high dose containing 20 micrograms of FLIPP-5, the major allergen of Timothy, is the same dose that was used in the Steve Durham study, and they looked at a dose that was 1/10 that much or at placebo. And if we look at the next slide, please, you'll see that the high-dose Timothy, although not as spectacularly effective as in the Steve Durham study, still resulted in a reduction in symptoms of 32% and rescue medication use of 41%, whereas the low dose, 1/10 that much, was fairly marginal in its performance with a 19% reduction in symptoms and only a 14% reduction in rescue medication use. Next slide, please. Now, of course, the reason that people tend to use low doses is for safety, and that's confirmed again here when we look at systemic reactions. With the high dose, there were 9 early and 39 late systemic reactions versus only 4% late systemic reactions in the low dose and 2% in the placebo. So there is more risk to the high dose, but on the other hand, if you're going to give immunotherapy and put people through the inconvenience, then you should give them enough to be clinically effective. Now, the next slide has a lot of data on it. This is data drawn from many studies, therefore you'll see a range of dosing. So on the left we have the extract that was administered. Next we have the major allergen of that extract. Next we have the effective doses in these many studies expressed as the major allergen content. Now, why do we do it that way? Because most of these studies are done in Europe, where each company has its own in-house standard, and there's no way at all to compare one to another. So the only useful way to compare these many studies is by the major allergen dose that was administered at maintenance. And then finally, you'll see on the far right that for many of these studies, there were lower doses administered, which proved to be either less effective, as in the case of the Tony Frew study, or totally ineffective. And you'll see in general they tend to be about 1/10 to 1/20 of the effective dose. You'll also notice that there is a relatively narrow range of effective doses when it's expressed as the major allergen content. So most of them are in the range of 8 or 10 up to 20. Next slide, please. Now, this has a lot of data on it. On the left are these same extracts. The next column has the way they're expressed in potency in the United States. The third column has the major allergen. The fourth has the mean content, and the fifth and sixth have the minimum and maximum content. This data was provided by Greg Plunkett, who's a PhD at ALK Laboratories in Texas, and he has run samples from every extract company in the United States, FDA standards. So this is the whole range of potencies that were available at the time. You see, this was 5 years ago. In the United States, there's little reason to think it's changed, and you see the mean content. Now we'll concentrate on the mean content because that's where the main message is. You'll see the 4 red ones at the top. Those are all standardized pollens, and you'll see they're all up in the hundreds. And if you look at the red one lower down, black birch, that's a non-standardized pollen, but it's right in the middle of the standardized ones. And I think it's safe to say that standardized pollens are no more potent than non-standardized pollens. They're all made the same way, and in general, when pollen extracts were standardized, if anything, they were diluted rather than increased in potency. So you can assume, I think, that pollen extracts are all up in the several hundred microgram per milliliter range. If you look next at the black ones below there, these are the perennial indoor allergens, and you can see that they're considerably weaker, about 1/5 overall of the potency of the pollens. And the weakest of all is cat. And then at the bottom in blue, you'll see dog epithelium, which is so low it really would be ineffective for immunotherapy. You would have to give 3 ml of the concentrate with each injection to give enough to be clinically effective. Fortunately, we have acetone precipitated dog made by Hollister Steer, and because of the methods involved in producing this acetone precipitated extract, it's quite more potent, and you can see it falls about in the middle between the perennials and the pollens. Next slide, please. Next slide, yeah. On the other hand, there are other non-standardized extracts which are of very poor quality. Here we see cockroach and a couple of representative molds. For one thing, you see that the range is huge. Some of them have virtually no antigen content. And if you look at the mean, it's quite weak. Cockroach is about the same as cat, and the molds are very low. I think it's questionable if any of these can be usefully used for immunotherapy. Possibly the cockroach used virtually undiluted. Next slide, please. So how do we use this information to calculate doses? Well, if you assume that you're going to make up a 10 ml maintenance vial, and you assume that the maintenance injection is going to be a 1/2 ml, then that 10 ml maintenance vial should contain 20 doses of the extract. For example, if the optimal Timothy maintenance dose should contain 20 micrograms of FLIP-E5, then the 10 ml vial should contain 20 times that much, or 400 micrograms. Now, we know that on an average in the United States extracts, the concentrated Timothy extract contains 600 micrograms of FLIP-E5 per milliliter. So if you take the 400 required and divide it by 600, it means you would put about 0.7 ml of Timothy into the 10 ml vial and fill it up either with diluent or other extracts, and when you deliver the 0.5 ml maintenance injection, you will be giving Timothy with 20 micrograms of FLIPE-5. Next, please. And this is the calculation then for the standardized extracts. You can see Timothy grass 0.7, as we said, short ragweed 0.5. The mites being less potent, if you give them alone, you have to give 2.3 or 2.7, but they're very cross-reactive, so they're often mixed. In that case, you give 1/2 that amount. Cat is very borderline. You have to put 7.5 ml in the 10 ml vial to deliver the proven adequate dose of cat. For the unstandardized, AP dog, as I say, is pretty good. Unstandardized pommons are virtually the same potency as Timothy and short ragweed. If you wish to err on the conservative side, you can use 0.1 ml of these non-standardized pommons, but you probably could give a little less. Next slide, please. Additional considerations in prescribing SCIT: cross-allergenicity of the various extracts, the effect of proteases in allergen extracts, and then we'll talk about the efficacy of SCIT with mixtures unrelated. Next slide, please. We won't go extensively into cross-allergenicity, but in general, the rule is that you don't treat them as distinct extracts. You either take the locally most important single species, or if there are several, as for instance here, for the Chenopod amaranth, we have both Russian thistle and kochia. We might use a 50-50 mix of the two. Examples of where you would make this decision would be the northern pasture grasses, where 8 to 10 grasses are almost completely cross-reactive. The weed family, particularly ragweed, where there's a high degree of cross-reactivity, the house dust mites, and the cedar juniper, where again, they're very cross-reactive. Next slide, please. An important consideration is that some extracts have protease activity that will break down the allergens in other extracts. The pommons, cat and dog dander, and U.S. house dust mite extracts do not have significant trypsin equivalent activity, but all of the molds and the cockroach do. Next slide, please. So a number of studies have been done in mixing, and they're all pretty much in agreement that you don't mix pollen, dander, or house dust mite extracts with extracts of fungi or cockroach. You don't mix fungal extracts with cockroach. They appear to have different protease activity. And for fungal and cockroach, you only use extracts that contain 50% glycerin, because otherwise they auto-digest and may contain no intact allergen at all. Next slide, please. Now we'll look at multi-allergen mixes. Next slide, please. This is an important point because the Europeans in general don't believe that you can mix allergen extracts, and they generally give monotherapy or separate injections if they give treatment with several different extracts. The studies that support this are quite old, but I think they're pretty good. The first one is a classic study by Doug Johnston. This is the sort of study, obviously, that could not be done any longer with informed consent and IRBs. But in those days, there was no such control, and therefore every child with asthma and positive skin tests who was referred to at Strong Memorial Hospital in Rochester, New York, was entered into the study. And they were randomly assigned to receive injections of saline, an extract which contained dilutions of greater than 1 to 1 million, an extract containing each extract at 1 to 5,000, or an extract containing each extract at 1 to 250 weight by volume. And they included all of the positive skin test inhalant allergens. So these were multiple allergen mixes. Next slide, please. It wasn't what we would do today, but the parents did not know that their children were in the study. Those who evaluated the patients were not aware of which group the child was in. So therefore, the Cochrane Review accepts this as a randomized, placebo-controlled study. In all, they enrolled 230 subjects. 173 were still in the study after 4 years, and 138 stayed until they were 16 years, in some cases getting injections for 14 years. There was a similar number of dropouts in each treatment group. Next slide. This shows the results after 4 years. They quizzed the parents, and free of asthma meant they had had no asthma in the previous year. So 4 years, 18% of the placebo and the very dilute extract had had no asthma. Presumably they had gone into spontaneous remission. But 58% of those receiving the intermediate concentration and 81% of those receiving the high dose had been free of asthma for 1 year. And you can see at the end of the study at age 16, a smaller number, the relative effectiveness is similar. Next slide, please. A truly set of elegant studies were done by Francis Lowell and Bill Franklin at the New England General Hospital. This was after Franklin Lowell had been president of the Academy and had bemoaned the fact that there were no adequate studies supporting the use of immunotherapy. So the way they did it, they took patients who were receiving injection therapy with ragweed, but other allergens as well. They monitored them through the ragweed pollen season of 1962, and out of the hundreds of patients they had in the clinic, they found 24 who still had significant symptoms during the ragweed season. Then the next March, they substituted caramelized sugar for the ragweed in one of each pair of the 12 pairs of patients. And then they continued to receive the injections with all the other allergens through the next ragweed season. The next slide. We see the results. The solid lines show the mean and median symptom medication scores for those who continued to receive ragweed in their allergen mix, and the dashed line are those who had had the ragweed removed some 5 months earlier. Next slide, please. They then repeated exactly the same study, but this time, instead of completely eliminating the ragweed, they reduced it by 95%. Why 95%? Because they had identified a number of practitioners who were giving this reduced amount of ragweed and claiming that it was effective. Next slide, please. Shows that indeed it wasn't very effective. The dotted lines show the reduced, those who received the 95% reduced dose of ragweed, and the solid lines, again, the mean and median for those who continued to receive the full dose. Next slide, please. We won't go into detail on the immunologic response, but it appears to be 2 steps. The first thing that happens very early is a production of allergen-specific regulatory T cells, which secrete IL-10 and TGF-beta. And these cytokines are probably responsible for many of the changes that occur, including probably a downregulation of the mast cells and the B cells, because by the time you reach maintenance and when these regulatory T cells are at their peak, you already have reduced the titrated prick skin test titer by 1 or 2 logs in many cases. Then this wanes towards the end of a year or so of continued treatment, and after that, the predominant immunologic change appears to be a shift from Th1 to Th2 to Th1 in the cytokine profile in T cells that are stimulated by the specific allergen that the patients have been receiving. Next slide, please. We'll now address what is probably the first the most important thing, I guess, is that immunotherapy greatly improves patients' symptoms. But the second important thing is that it modifies the underlying immunologic response and therefore has persisting benefit after it's been discontinued. And we'll look at its prevention of new sensitizations in monosensitized subjects. We'll look at the prevention of the progression to asthma in subjects who only have allergic rhinitis. And we'll look at the persistence of improvement for years after discontinuing treatment. But all of these effects persist after treatment is discontinued. Next slide, please. First study is one by Giovanni Paino from Sicily, Italy. His group had 134 children with mild asthma without rhinitis. They were sensitized only to house dust mite. They were all offered, or their parents were all offered immunotherapy. 75 of the parents accepted immunotherapy, and 63 of the parents rejected immunotherapy. So that became the treated and the control groups. Next slide, please. They administered immunotherapy, but the results below are recorded at 6 years, 3 years after the immunotherapy was discontinued. The maintenance dose here in these young children was about half of the customary adult dose. And at the end of 6 years, new sensitization had occurred in about 25% of those who had received the house dust mite immunotherapy, and about 2/3 of those who had only been on symptomatic medication. Almost this same ratio has been repeated in 2 other studies. Next slide, please. This is the famous PAT study, Prevention of Asthma by Therapy. This was done in several countries in Northern Europe. The children were 7 to 13 years of age. They had allergic rhinitis. They were followed through one baseline season to be sure that they had no asthma symptoms. They were then randomized, depending on their sensitivity, to birch, timothy, or both. They received it for 3 years on a continuous basis. It was stopped, and then they were followed up 2 years and 7 years after its discontinuation. Next slide, please. And this is the results. We have 3 years, the end of immunotherapy, 5 years and 10 years, the 2 follow-ups. What each shows is the number who do not have asthma over the number who have developed asthma. So for SCIT, we see 60 without and 19 with, 60 and 15, 48 and 16. We see in the control group 40 have no asthma, but 32 have developed asthma, and similar through the next follow-ups. And we see the odds ratio for not developing asthma if they received immunotherapy, and we see a very consistent odds ratio, not only at the end of the 3 years of immunotherapy, but 2 and 7 years after it's been discontinued. Next slide, please. We'll now look at 2 studies that address the duration of immunotherapy. This is one of the few studies that looks at a group of people who received immunotherapy for varying periods of time. So this was done by Jean Bousquet in Montpellier, France. 40 house dust mite sensitive asthmatics received immunotherapy for anywhere from 12 to 96 months. They received immunotherapy until they were symptom-free for 3 months. Then the controller medication was stopped, and then they still had normal pulmonary function and remained symptom-free. So when they met those criteria, immunotherapy was discontinued. They were then followed at 6-month intervals for the next 3 years to see if they relapsed, and about half of the patients did. One of the determinants for persisting benefit was related to the duration. We see that on the next figure. At first you might think there's no difference, but there actually is. You'll see more clustered on the left, those who did not relapse, up at 3 years and above. You'll see very few 3 years and above who did relapse. And on the other hand, you'll see many who did relapse who received less than 3 years. And the next slide points this out a little bit more clearly. It's a Kaplan-Meier slide. It looks at, in spotted orange, the relapse rate in those who received immunotherapy for 3 years or more, and in yellow, those who received less than 3 years. And we see, for instance, at the end of 1 year, 84% of those who had received 3 years of immunotherapy had persisting, versus only 41% of those who had received less than 3 years. Next slide. This study is the more typical one. It's out of Vienna, Austria. 108 patients who received grass pollen immunotherapy for 3 or 4 years for their allergic rhinitis. They had virtually complete clearings. So therefore, their immunotherapy was stopped, and they were followed annually for the recurrence of symptoms. Next slide, please. Each of these represents 1 year after their 3 or 4 years of treatment was discontinued. You can see the first pollen season, only a few percent relapsed. About 17% relapsed the second year. About 30% relapsed the third year, and not many more the fourth year. So relapse does occur. The duration of remission varies with the dose, with the duration of treatment, but it also varies with the individual. So you can't tell somebody you're going to be good for 10 years. You can say that on an average, people may be good for 10 years, but some will relapse earlier and some will relapse later or never. Next slide. The drawbacks, inconvenience, and systemic reactions. Next slide, please. This study emphasizes the fact that cutaneous immunotherapy is inconvenient. 46% of 217 patients discontinued their injections during the first year of treatment. It's pretty high, and it's been confirmed in other studies, although other practices do much better. But in these patients who discontinued, inconvenience was the reason given for over half of those who only had allergic rhinitis, but for fewer for those who had asthma. Clearly, patients with asthma are willing to put up with more inconvenience than patients who only have allergic rhinitis. This, therefore, is a recommendation for more rapid buildup schedules, such as cluster, which mean fewer visits, less inconvenience, and perhaps better adherence. Next slide, please. Now we're going to look at systemic reactions, and these are 2 reports from very large studies. Dave Tinkelman from Atlanta and Lynn reported the data from Friday's clinic in Pittsburgh, Pennsylvania. You'll see they're in agreement for many things. Systemic reactions occurred more during buildup than maintenance. Both found that they were not increased during the pollen season. This is a very contentious issue. Many practices automatically lower the dose during the pollen season because they think that increased danger of systemic reactions. Neither of these studies found it. Looking at the last bullet, you'll see that all the severe reactions with hypotension in the Tinkelman's practice occurred within 30 minutes, and most severe reactions in the Friday practice occurred within 15 minutes. That's why the 30-minute waiting period. There is a bit of disagreement in that Dave Tinkelman found no effect of age or gender, but in the Lynn study, which was larger, as you'll see, they found an increased incidence in women and those who were most sensitive to the particular extracts, and ages 10 to 30, who are the people who are most sensitive. Next slide, please. And this is a figure from the Lynn article. This shows across the bottom the different months. Pink are systemic reactions that were thought to be due to grass pollen extract. The brown are those that were thought to be to ragweed pollen extract. The green peak is the grass pollen season. The red peak is the ragweed pollen season. And you can see there was no tendency to increase systemic reactions during the specific pollen seasons. I think this is rather convincing data. Next slide. This was supported by a poster at last year's college meeting. The group at Wilford Hall reviewed the timing of all the SCIT-associated systemic reactions. It required treatment with epinephrine over a period of 8 years in their clinic, and they examined them in relation to the mountain cedar pollen season. Next slide, please. We see here grouped two groups, those who are mountain cedar allergic and receiving mountain cedar in their extract, and those who were not mountain cedar allergic and therefore were not getting mountain cedar in their extract. And we see during the mountain cedar pollen season, the same percentage of both groups had systemic reactions as they did out of season. So there was no suggestion that mountain cedar allergic patients or those receiving mountain cedar pollen extract were more susceptible to systemic reactions during the mountain cedar season. Next slide, please. What is very convincing, I think, is this study from Jean Bousquet. These were patients with asthma who were getting rush immunotherapy with house dust mite extract. And we're looking across the bottom at their FEV1 the morning before they began their rush immunotherapy. The red are those who had no systemic reaction. The green are those who had anaphylaxis, and it didn't matter what their FEV1 was. But the yellow is those who had systemic reactions manifest by asthmatic symptoms. And you can see that those who had normal FEV1 the morning of rush had a very low incidence of systemic asthmatic reactions, and those who had decreased FEV1, particularly below 70%, were very susceptible. Next slide, please. We're now looking at two retrospective surveys that were done by the American Academy of Allergy and Immunology Immunotherapy Committee. The first one by Mike Reed, and the second one by Dave Bernstein. You can see they covered a period in all from 1985 to 2001, and over this period of time they identified 37 fatal reactions in allergy practices. And they highlight certain things that are the risks. And the first is asthma. You'll see 88% of those in whom it was known whether they had asthma or not did indeed have asthma. So the fatalities are primarily in asthmatic patients, and primarily in patients with severe asthma, with labile asthma, who are having symptoms before the injection. The two other risk factors are first dose from a new vial. This presumably is because of deterioration of the extracts, and then a more potent extract in the new refill, and then finally 15% due to dosing errors. Next slide, please. Now, since 1908, rather than the retrospective studies, there's been an ongoing online attempt to acquire this information, supported by both the Academy and the College. The participation has ranged from 27 to 51% of the allergists who are members of the College and the Academy. In all, they've obtained data on 28.9 million injections. Next slide, please. They've looked at systemic reaction rates, which are very consistent, about 1 for every 1,000 injections, but very few of these are serious. Grade 3 are those multiple allergen, multiple organ, and often with asthma, and the 1% are those with severe asthma requiring intubation or hypotension. And you see they constitute 5%, or what would be 1 in 20,000 injections. They identified 2 fatal reactions in allergist practices, one in 2009, one in 2014, and 2 fatalities in non-allergy practices, an ENT and a family practice on which they have no details. But prior to 2002, in the retrospective studies, there was about 1 fatality every 2 to 2.5 million injections. And the current one identified 1 per 14.5 million injections. So it certainly suggests that there's been a major improvement in safety, and the presumption is that this relates to more care in administering immunotherapy to patients with asthma, particularly monitoring their pulmonary function before they receive the injection and before they leave the clinic, and not giving it to those who have been symptomatic. Next slide, please. Even though the subject is subcutaneous, I think it's appropriate to have a couple of comparative studies here, because there are 2 different forms of immunotherapy available. And the first one we're looking at is the best study that compares head-to-head subcutaneous and sublingual immunotherapy. I wrote an article for Jackie in Practice a couple of years ago, looking at all the articles that were direct comparisons, of which there were 11, but most of them used their slit less than daily, 9 out of 11, so they were suboptimal, and also the doses employed were often quite low. So even though it made SCIT look better, it was probably an unfair comparison. Here we have a study that uses the approved doses of ALK products, the 75,000 SQ unit slit tablet, which is the one that's approved for use in the United States, and the 100,000 SQ every month or 2 months maintenance subcutaneous, which again is their approved treatment regimen. It was a 15-month study, and the outcomes were assessed by nasal challenge with Timothy grass and by measuring the IgG4 response. Next slide, please. This slide looks at the nasal response, nasal challenge response to Timothy. So across the bottom we see the 15-month duration of the study. Down is better in this case, fewer symptoms. The green are the control group. The yellow dashed line is those receiving the sublingual, and the red dashed line is those receiving the subcutaneous Timothy. You can see at 3 months, the subcutaneous results are significantly better than both the slit and the control. You can see that subsequently the subcutaneous continues to be significantly better than the control. It is no longer significantly better than slit, but slit is never significantly better than the control throughout the study. Next slide, please. This looks at the IgG4, which is reflective of regulatory T-cell generation and secretion of interleukin-10. Again, we have the green is the control, the yellow is the slit, and the red is the subcutaneous. Here, both active treatments are significantly better than placebo throughout their course. The subcutaneous is significantly better than slit throughout the entire course of the treatment. Next slide, please. And finally, the last slide. One problem that has emerged, one problem with immunotherapy in general and all chronic treatment is adherence. But adherence problem has particularly appeared with slit. There was a big study from Italy where the manufacturers reported on persistence, and it was down to 13% by the 3rd year of treatment. This study is from the Netherlands and uses their pharmacy database. They were able to track refills on about 2,800 receiving SCIT and about 3,700 receiving SLIT. And they tracked them for 3 years for refilling their prescriptions. Only 23% of those receiving SCIT were still refilling their prescription at the end of the prescribed period, but it was only 7% of those who had been prescribed SLIT. And when they looked at the mean duration of persistence, it was 1.7 years for those who had been prescribed subcutaneous, but only 0.6 years for those who had been prescribed sublingual. So, as in a number of other studies, although adherence is poor with the subcutaneous, it's considerably better than it is with slit. All right, that's all I had to say, and I'll be happy to answer any questions.
Well, thank you so much. That was a nice overview. Any questions or comments from either the fellows or the folks out in Cololand or anybody else?
Dr. Nelson, I have a question. This is Paul Dowling. Because of the proteases, I'm just curious how many, if you start someone on immunotherapy, how many injections are they actually getting? Because if you have someone who is on pollens and house dust mite and fungi, which we commonly see, not alone talking about if someone has the cat that they want cat therapy for, I would see that you're talking about 3 or 4 shots. Is that what you do?
Well, unfortunately, that's what you have to do. Paul, the alternative is ineffective immunotherapy. So, considering how potent the pollens are, you can certainly put a lot of pollens in, and the house dust mite is pretty good. You can certainly probably get away with dog, cat, and house dust mite in one without greatly compromising therapy. You can certainly put every pollen you could conceive of into a vial without getting running out of space. I personally, I never treated much with molds, except alternaria occasionally. But I think if you're going to treat with molds, you have to make them separate. It breaks down the other extracts quite quickly. In the study we did, we tested it at 3 months, and it had a profound effect on the other extracts.
So you give cockroach separately as well?
I've never given cockroach. If I were to give cockroach, yes. I mean, you have to. People at Greer looked at mixing. We used to think you could mix them together, but the folks at Greer looked at mixing mold and cockroach, and each one reduced the potency of the other. So I think, if you have to give, and cat and dog and house dust mite and molds and cockroach, you're talking of 4 shots.
That's kind of a hard sell for pediatrics.
Well, maybe you have to be selective. We tend to. I'm afraid I'm guilty of it too. I used to say, well, if I want to have somebody come in for shots, I want to be sure I give them everything that they're allergic to. And the Europeans don't do that. They're very selective. They say, well, we'll only take the most important allergens and treat them, because of course they don't use mixes, and they do give different injections for each one. So they may say, well, this person has to have grass and birch and house dust mite, and they'll give 3 shots. But maybe we have to be more selective. If we're more selective, you can certainly probably get the all of the cat, dog, mite, pollen into one. But you're still, if you're going to do mold and fungi, I don't know any way around giving them separately.
The fact that that they're at least with Greer, it's 50% glycerinated or whatever. Does that? I always thought that would be helpful against the proteases.
Well, it is. It is, and there is an article. I'll be perfectly frank, by a guy from Greer, PhD. I think his name actually is Greer, except it's spelled G-R-I-E-R instead of G-R-E-E-R. Who reported? Is that right?
Tom Greer, yeah. He works at.
Anyway, he had a recent article that said you could mix them. There's an awful lot of literature that contradicts that. And I think that you have to be careful, because different batches of fungi, and at least fungi, I don't know about cockroaches, have different protease activities. We've looked at batches of the same fungus and had a different effect on pollen extracts. So I'm very leery about that. But you should be aware there is that article if you want to look at it. I think it's in the annals.
I have a comment and a question. First of all, I want to thank you for being our premier speaker today. Obviously you're the expert on many of these topics, and we're really honored that you agreed to kick off our new season. In terms of the proteases, I worked with Bob Ash back in the 1980s when we were looking at fungal proteases and how they interacted with pollens, and our conversation was that yes, they do reduce the IgE binding ability of these other extracts. So in that case, they reduced their potency, but we never knew whether that actually affected the immunotherapy effectiveness, because that's never really been studied. So even if the IgE binding potency is diminished, the peptides that occur as a result, the breaking down, those might still be very effective. They might even be more effective. So we don't know that these extracts are less effective in terms of how well they work for immunotherapy. All we know is that they don't cause an IgE reaction as much because they've been digested or broken down. Obviously, it's an uncontrolled breakdown and digestion, so we don't know whether that harms the T-cell peptides that might be useful or whether it just allows them to work more effectively. So that part of it is actually not known. All we know is that mixing these things together.
You're absolutely right. You're absolutely right. That potential exists. Unfortunately, it's never been tested.
Yeah, study's never been done. That's the problem. But my question to you is the advantage of SLIT, sublingual immunotherapy, was supposed to be that it was convenient. People could do it at home, and it was so nice. And I'm interested to see that the compliance is actually poorer for that. And do you have any sense of why that might be, or why people don't do this?
You know, actually, Jay, it looks like some of the studies that Bruce Bender here at National Jewish has done on adherence with inhaled steroids, which drops off. I mean, apparently it's the lack of reinforcement. There was a good study by Giovanni Paino in which they prescribed a bunch of kids SLIT, and then they brought them back once a year, twice a year, or 4 times a year. And it had a profound effect on adherence. It was quite good in those who came back 4 times a year, was middling in those who came back twice a year, and was dismal in those who came back once a year. So I think it's the lack of reinforcement. And that's
really
probably
need to
why
bring these patients back. We need to bring them back more frequently then, right?
Yeah, bring them back quarterly. I mean, the adherence, I don't remember the exact figures, but it was something like 65-70% adherence with the quarterly visits and 15% adherence with the yearly visit.
Wow. Would that work with subcutaneous also?
Well, of course, there we reinforce it. Nobody goes more than a month between injections.
That's true.
And I think very often some people may call those who don't come in, but at least there's a lot of contact, personal contact, and that apparently reinforces it. You know, Dave Tinkelman, I don't know your experience, Dave Tinkelman talked about dropout rates of 10% with courses of subcutaneous.
You've got to be really nice and reassuring and encouraging.
That's right. And call them if they don't come in is probably another way to reinforce it.
Wow. Okay. Very good. Any other last questions before we end today? Well, thank you so much.